So today we are going to learn another rule of exponents, okay? And I really think this one is simpler, maybe, than the zero and negative exponents. Now here's the thing though, the zero and negative exponents is still a thing, okay? You do not have an answer in simplest form if you have a negative exponent. Okay, so that's still a thing today. But we're going to throw in a new rule today. This rule is called multiplying powers with the same base. So remember, we have, using the correct vocabulary, what I think we oftentimes call an exponent. I usually look at this and I'm like, oh look, it's an exponent. But remember, the only thing that's the actual exponent is the little number. The big number, so in this case the a, is the base. The whole thing, the a to the m, the a to the n, the whole thing is a power. So what we're doing today is we're multiplying powers, so the whole thing, but they're going to have the same base. Okay, so the same big number. This rule, super simple. When you're multiplying powers with the same base, you're going to add the exponents. So, for example, if I have a cubed times a squared, multiplying powers, they have the same base, it's both an a. This is going to be a to the fifth. 3 plus 2. Okay, now, I'm a big y kind of person. We need to know, well, why do I add the exponents? If I were to expand this out, let's see what this would look like. A cubed means a times a times a. And a squared means a times a. So, if I were to write it out like this and then scrunch it back up, I have a cubed, I have 3 of them, and a squared, 2 of them, 3 plus 2, right? That's your a to the fifth. That's why you add the exponents. Now, the big thing that you need to keep in mind today is they have to have the same base. So, if I have a g cubed, and then if I have an h squared, and then a g to the 4th, not all of these have the same base, the same bottom number, right? I've got the g, and then I've got an h, but then I've got this g over here. They have to have the same base if you're going to add their exponents, because here's the thing, g cubed is g times g times g, h squared is h times h, and then g to the 4th is g times g times g times g. So if we were to expand it out, which we're not going to do this every single time today, of course, but then if you were to scrunch it back up again, here's the thing. I couldn't write this as gh to the 5th. It doesn't work that way, right? I've got these 3 g's over here, and I've got these 4 g's over here. We can rearrange these, and I could write all of these g's right next to each other, and I'd have the 3 and the 4, and I would get a g to the 7th. And then the h times h would just stay in h squared. So as long as they have the same base, you can add their exponents. If they don't have the same base, they just stay separate. Okay? All right, so let's get this glued into page 69. This should be section 7.2. Multiplying powers with the same base. Okay, so like I said in the beginning, I'm a really big y person that we are going to learn. So we learned our zero exponents and our negative exponent on Monday, practiced on Tuesday. Today we're learning this rule. And here's the thing, tomorrow I'm going to throw 2 more rules at you. Okay? And the rules are really similar, so especially one of the ones we learn tomorrow is really easily confused with the one that we're doing today. So understanding the why is really important, because if you confuse the rules, if you're not sure, well, am I supposed to add the exponents? Am I supposed to multiply the exponents, subtract them? What am I supposed to do? If you understand where the rule comes from, if you get a problem that you're not sure what you're supposed to do with the exponents, you can expand out your power. And you can say, oh yeah, this is the one where we add because, and then you can apply it that way. So super big on the why, okay? So number 1, if I have b cubed 6 times b. So remember the rule today, we're multiplying powers that have the same base. The big number, the b, it is all the same. So what I can do here is I can add the exponents. So 2 of them I see, 3 plus 6 plus, but I don't see a number there. And it's going to be a 1. Kind of like, I don't see a number in front of the b. It's a 1, we just don't normally write it. If you don't see an exponent, there is a 1 there. Because think about it. This is b cubed, b times b times b. This is b to the 6, b times b times b times b times b. 1, 2, 3, 4, 5, 1 more. And then I've got another b, right? Just another b. So I've got 3 of them and 6 of them and then 1 of them, and I should get b to the 3 plus 6 plus 1, 10. B to the 10. Okay, number 2. Okay, number 2 says in parentheses a to the 4th, b cubed, and then in the second set of parentheses, a squared, b to the 5th. Okay, now, I think what happens in a lot of these, they look more confusing than they are because there's parentheses. We're not sure what exactly we're supposed to be doing here. But you think about it, these parentheses, if there's not a sign, like a plus, minus, division, anything like that, the parentheses just mean multiplication. This just means I'm going to take a to the 4th b cubed times a squared b to the 5th. I'm just multiplying these two things together. Okay? And remember, for multiplying, the order doesn't really matter. So technically, I could flip these parentheses around. Wouldn't matter. And actually, inside the parentheses, I have a to the 4th times b cubed. So inside the parentheses, I also have multiplication. So all this is just a big multiplication problem. So if it's all a big multiplication problem, I could rearrange all of these, which is what I'm going to kind of have to do in my head at minimum, okay? And I can put the a's next to each other because they have the same base. And I can put the b's next to each other because they have the same base. So I could take a to the 4th times a squared, and then I could take b cubed times b to the 5th. And then remember, what I do with these exponents is I add them because this is an a to the 4th and an a squared. If you were to expand that out, you'd have 4 plus 2, you would have an a to the 6th. And the same thing with the b's. You'd have a b cubed, 3 of them, and an a to the 5th, 3 plus 5, you would have a b to the 8th. Okay, now, you don't have to write that step out. If you want to, great. But just kind of showing you that we can only add the exponents of powers that have the same base. So even in our head, we have to kind of rearrange them and put those same bases next to each other. Okay, number 3. In parentheses, negative 3x to the 4th y times, second set of parentheses, 2x to the 5th y to the 6th. Now once again, I think a lot of these problems look more complicated than they are, but I'm multiplying two things together. Negative 3x to the 4th y times 2x to the 5th y to the 6th. Multiplying these two things together. And inside the parentheses, it's negative 3 times x to the 4th times y. And in the second set of parentheses, it's 2 times x to the 5th times y. It's just a big multiplication problem. That's all it is. So even if you don't write out this step, what you're doing in your head is you're kind of picking out the things that you can actually multiply together. You can multiply the x's together and add their exponents. You can multiply the y's together and add their exponents. And you can multiply negative 3 times 2, right? So you're going to take negative 3 times 2 and you get negative 6. You take x to the 4th times x to the 5th, and you would get x to the 9th. Add the exponents, and you would take y, which is a 1y, right? Times y to the 6, I don't have that many fingers, which would be y to the 7th, yeah. 1 plus 6, that would be your answer there. So we're adding exponents for powers that have the same base. Keep that in mind, okay? Because I can picture these, I can see these. Because next, I'm going to throw this out here. X to the negative third times x to the fifth. I like to start with the positive exponents because I can picture those. I can expand those, okay? And that's a little bit harder to do when I have a negative exponent, but the rule's the same. They have the same base, don't they? We do the same thing. You add the exponents, just like here, how you took x to the fourth times x to the fifth, 4 plus 5 gives you x to the ninth. You do the exact same thing. This is going to be x to the negative 3 plus 5, 2. X squared. That's it. That's all you have to do. Add the exponents. Okay, let's take almost that same problem. Let's do x cubed times x to the negative fifth. X cubed times x to the negative fifth. Same thing. I'm multiplying powers that have the same base. So you're going to add their exponents. And it's going to be x to the 3 plus negative 5, negative 2. Here's where it comes in what we did on Monday and Tuesday. I cannot leave my answer as a power that has a negative exponent. But this is easy to fix. We practice this a lot. How do you fix a negative exponent? How do we fix the negative exponent? What do we do on Monday and Tuesday? Yeah, flip it over the fraction bar. This is in the numerator, so you're going to move the x to the denominator. The negative 2 becomes a positive 2. And I've got nothing left in my numerator, so we'll throw a 1 up there. You get 1 over x squared. So same rules for Monday and Tuesday. It all kind of flows together. Okay, what if I have 3x times 4x to the negative 4th? Maybe it looks a little different, but guys, this is just a multiplication problem. So multiply the things together that you can multiply together. I can multiply 3 times 4 because they're just coefficients. 3 times 4 is 12. I can multiply the x's together because they're powers that have the same base. When you take x to the, what number is there? 1. When you take x to the first times x to the negative 4th, you would get x to the 1 plus negative 4. You add the exponents, you get negative 3. Okay. The last thing, make sure your answer is in simplest form, which means if you have a negative exponent, can't leave it like that. Now, be careful here. What has a negative exponent? The x. And only the x. Only the x. The 12 does not have a negative exponent. The 12 stays in the numerator. Only the x moves down to the denominator and the negative 3 becomes a positive 3. I think that's one of the hardest things to remember is that the 12 and the x, they aren't attached. They're not one thing. They're separate. Okay? Let's try another one. Number 7. All right, in parentheses, negative 3, x to the negative 3rd, y to the 4th, times, in second set of parentheses, negative 4, x to the negative 2nd, y to the negative 2nd. So really similar to the last one, just kind of a little more going on. You want to pick out the things that you can multiply together because I know there's negatives, I know there's x's, there's y's, there's numbers, there's parentheses, there's so much going on here, but it's all multiplication. That's the only thing that's happening here. It's a bunch of stuff multiplied together. So I can multiply the coefficients. I can multiply negative 3 times negative 4. I'd get a positive 12. I'm going to multiply my x's. X to the negative 3rd and x to the negative 2nd would give me x to the negative 3 plus negative 2. Add negative 5. And then I'm going to multiply my y's. Y to the 4th times y squared, y to the 4 plus negative 2, 2. And then the last thing you want to do I have negative exponents? What has a negative exponent? The x. and only the x. So the 12 and the y squared, those are going to stay. But I'm going to move the x down to the denominator. The negative 5 becomes a positive 5. Okay, number 8. What if we do 6xy to the negative 3rd times negative x to the 4th y? Okay, once again, this is just a big multiplication problem. So you're going to multiply the things together that you can. So I kind of like to start with the numbers, just to get those out of the way. And I see a 6, and there's not a number there, but there's that negative there, and it always gets really confusing because it kind of looks like maybe it's a subtraction, but it's not a subtraction. What number is this? It's a negative x. What's in front of the x? A 1. That's actually a negative 1. So you're going to take 6 times negative 1, and you get negative 6. I would take x to the 1st times x to the 4th. I would get x to the 5th. Add 1 plus 4. And then y to the negative 3 plus 1. Y to the negative 2nd. Now be super incredibly careful here because I have students that just go crazy with moving stuff all over the place. Like, oh, I see the y has a negative exponent. Oh, and that's 6. So I'm going to move the 6 and the y. Am I going to move both of those? Which one don't I move? Why don't I move the 6? It's negative. It's not an exponent. You only move negative exponents. Negative numbers are fine. We've never had to move negative numbers, right? It's a negative 6. That's it. So the negative 6, the x to the 5th, that stays. Don't move the negative numbers. Move the negative exponents. The y moves down, and the negative 2 becomes a positive 2. Okay, just a couple more. Okay, number 9. In parentheses, negative 12xy, and then in parentheses, negative 3x to the negative 2nd, y to the negative 2nd. Once again, and all of your problems today are going to be this way, guys. It's just a bunch of negatives being multiplied together. So multiply the things together that you can. So I can take negative 12 times negative 3. Should give me a positive 36. When I take x to the 1st times x to the negative 2nd, I would get x to the 1 plus negative 2 is negative 1. And actually, same thing happens with the y's, right? Y to the 1st times y to the negative 2nd, 1 plus negative 2, also going to give me y to the negative 1st. Which is not your final answer because I have negative exponents, so what needs moved here? Yeah, the x and the y. The 36 stays, the x moves down, and the y moves down. Now when you do that, the negative 1 becomes a positive 1. You can absolutely write x to the 1st, y to the 1st, but you don't have to. And most of the time, I guess if you're checking your answers, or most places will not write the ones, but you definitely can. If you write the positive ones, I would not take off points for that. Okay, last one, number 10. xy to the negative 3rd times, in parentheses, 15x cubed y to the negative 4th. So similar to the last handful of problems, except there's not parentheses around it. But this is all still just multiplication. This is going to be x to the 1st, y to the negative 3rd times. Okay. So my numbers, I've got the 15. I guess technically I have a 1 here. Just be 15 times 1. Just going to be a 15. When you multiply your x's, x to the 1st times x to the 3rd would be x to the 4th. Good. 1 plus 3. And then y to the negative 3 plus negative 4. Excellent. Negative 7. And then what's the last thing I need to do? Yeah, move the y. And only the y. We're going to leave the 15x to the 4th. Flip that y down to the denominator. And off we go.